Hello. Welcome back to Astronomy in the News for August of 2016. Is that the right year? I am Astrobit, your Astronomy in the News host. I'm once again missing my co-host. MCXO was supposed to be here this month. She helped me put together the slides and the talk. Unfortunately, she had this crazy idea of buying concert tickets in advance and not realizing it was tonight. So she's off at some music concert. Waste of time, especially in Austin. Okay, so beginning this month's Astronomy in the News, we start with the Large Underground Xenon, or LUX Dark Matter experiment. It's located in the Black Hills of South Dakota, an underground mine, deep underground. A giant tank of xenon completed the most recent and most sensitive to date search for dark matter, with no success in finding the elusive particle. So we still do not have a dark matter detection. This is not the end of the search. The lack of detection from LUX, as well as many other searches, have placed constraints on what dark matter looks like. If you want to know more about this, I'll put a little plug-in for myself. Come back next month. I'll be talking about these experiments in dark matter. So the Large Hadron Collider in Switzerland is also searching for dark matter. It is yet to find anything else either. I'll explain all of that next month. The LUX experiment is going to continue on in 2018. There's going to be an even more sensitive version of it, so keep posted on this very interesting topic. Okay, next, BOSS, the Baryonic Oscillation Spectroscopic Survey. I have to look it up. It released the most detailed 3D map of the universe to date. So what you're looking at here is kind of 2D representations of all of this. Every little speck you see there is a galaxy. It's a giant map of galaxies in the universe. What the BOSS survey is looking for is very subtle variations in the distribution of these galaxies. It's looking for what's called baryonic oscillations. Essentially something like ripples in a pond at the beginning of the universe that causes like small variations, small waves within the universe at very early times. These variations are seen in the cosmic microwave background. That happens at about 200,000 years after the beginning of the universe. BOSS is looking at what the universe looks like about 7 billion years after that, looking for those same tiny variations. The BOSS and cosmic microwave background both agree very well. The maps also reveal that galaxies are moving towards regions with more mass, which is what we'd expect. There's higher gravity. Things are moving towards more gravity. This is an independent validation of Einstein's theory of general relativity, perfectly consistent with Einstein's theory. So looks like Einstein is yes, still correct. Next up, a team led by Eleonora Troja of the University of Maryland looked at the aftermath of a gamma ray burst. This is what you see in an artist rendition on the left here, using the Chandra X-ray satellite and several ground-based telescopes. The type of gamma ray burst that they observed is likely the result of two neutron stars merging. This is something that we've known for a while, but also something that we've learned from this study. The collision from these two neutron stars as they spiral inward causes this massive explosion and this jet of material, what you see shooting out the top and bottom of this picture here. The jets are highly energetic and release a burst of gamma rays, hence they're called gamma ray bursts. The burst lasts for less than a second. Eleanor's team found that the GRB the gamma ray burst showed the similar behavior both in gamma rays, X-rays, visible light, and infrared light. First time that this has been observed. In order for that to happen, the entire width of that beam can only be about 5 degrees across. If you take your hand, extend it outward, the full length of your arm away, and look at it, your hand is about 5 degrees across. So this is a really, really tightly focused beam. In order for it to be that focused, it must be that something like that neutron stars or something very similar to it, very compact objects that are responsible for what's causing these. Not only that, the jet must be very, very directly pointed at us in order for us to see it. The gamma rays are only coming out through that jet. If that jet is pointed just a little bit off, we're not going to be able to see it. So we only see about 4 of every 1,000 of these events. So for every one that we see, there's a few that happen per day. There's 250 times, 996 more that we haven't seen. Okay. Artemi Campus Farina? Some of these names get really tough. A researcher at the Institute of Astrophysics on the Canary Islands, lovely place to be doing astronomy, they discovered a star cluster in a nearby galaxy in which they see 3 concentric shells. It's described as a matryoshka. The Russian nesting dolls that you've probably seen, the dolls that are nested inside of each other. What you see here, this is unfortunately an artist's conception. I looked at the original pictures, they're not nearly this pretty. But what you have in the center is a star cluster, lots of bright young stars, and 3 very concentric rings around them. What these are the remnants of supernova, what Jeff was just talking about. Because we've got a young cluster of stars, it tends to produce massive stars, they tend to go supernova. So we've got the outermost ring is the oldest supernova that occurred within this cluster. The middle one is slightly younger, than the center one is the most recent. The outermost ring was the supernova that happened about 115,000 years ago. The innermost ring happened about 20,000 years ago. The filaments in the rings are the result of the material running into material outside of the cluster and causing like little dips to occur as the supernova expands. Astronomers have just discovered a small dwarf galaxy forming an even smaller dwarf galaxy right next to it. Monica Tosi of the Italian National Institute of Astrophysics was part of the team who discovered this. It's a good sign suggesting that small galaxies help smaller galaxies form, or even large galaxies help small galaxies form. Essentially, what happens here is the small dwarf galaxy has just enough gravity that all the stuff next to it's kind of falling inward, kind of joining up, and as it falls inward, it triggers its own little burst of star formation, forming this new galaxy. It's important that this sort of thing happen because we need to explain how all the galaxies that exist in the universe and all the tiny little galaxies that exist around us are there. All right, next up, Edmund Hodges Kluck. Lots of triple names in astronomy. I don't know why that is. Edmund Hodges Kluck, a graduate student at the University of Maryland, observed the signatures of the halo of our galaxy. What you see here, kind of the big blue blob, giant blue blob. Our galaxy is this really small spiral galaxy that you can see in the middle there. He discovered that the halo of our galaxy is rotating. This is a very surprising result. What we expected is that when we look out at the halo consists mostly of just gas and a little bit of dust. We mostly expect that if you see any little piece of the halo, there's as many pieces going to the left as there are going to the right. So what we consider to be uniform motion. And what he found out is the halo is actually rotating. It's rotating only about 75% as quickly as the rest of our galaxy, which is relatively fast. Especially considering that we did not expect any rotation whatsoever. So this is going to drive new theories and new information about how galaxies form. All right, moving closer inward now within our galaxy, astronomers at the European Southern Observatories discovered that the system AR Scorpii is pulsating jets of radiation. What the system is a relatively normal star as well as a white dwarf. The white dwarf is shown in the upper right here. The white dwarf is accreting some small amount of material. It's accelerating electrons around it, causing very rapid, brief, bright bursts of radiation. These two systems are orbiting with a period of about 3.6 days, so that white dwarf goes around the other star or perhaps the other way. Actually, it's probably the big star goes around the little star about every 3.6 days. But the jets pulsate every about 2 minutes, so very, very rapid pulsation. The exact mechanism and causes of this are unknown. We never expected to find anything like this. This is a very new and interesting discovery. Moving into our own solar system, NASA has discovered the presence of canyons on Saturn's moon Titan. Shown here, I think the little white circles, not that you can really tell that those are canyons. Saturn's moon Titan is the only other planetary body in the system known to have naturally occurring liquid, mostly something like oil, hydrocarbons, pretty nasty stuff, nothing that you want to go swimming in. Yeah, seas of methane, and those seas also branch off into rivers and canyons. Astronomers at the University of Rome have suggested that the canyons that they've found have to be formed either by earthquakes or variations in sea level. Either way, the geologists have a lot of explaining to do, because we did not expect to find anything like these sorts of features at all. All right, and last up, our closest planetary neighbor, Venus, just discovered and just recently announced by NASA that Venus was probably habitable up until very recent times, astronomically speaking. So a team at NASA Goddard simulated 4 different versions of early Venus, and the most promising of those simulations had a relatively moderate temperature and enough clouds that protected Venus from the harsh radiation of the sun. This means that Venus probably had water and was effectively habitable to human-like life up until about 715 million years ago. Drop in the bucket in astronomical terms. On the other hand, you also have to consider that every form of life that as we know it here on Earth formed within the last 400 million years. So, drop in the bucket in astronomical terms, but perhaps not in evolutionary terms. But this is very promising that perhaps we've been, chasing the wrong things on Mars. Maybe Venus is where we've been should have focusing our search for life all along. So keep posted on this. That is all I have for Astronomy on Tap for August. I will hand it off to ASAP Rocky Planet. And come back next month. MCXO, I promise, will be here with me next month. Thank you.